In the part 1 of this module, we have seen the anatomy of an HTTP request. We continue our discussion with this diagram that illustrates the structure of an HTTP response message, which is used by a server to communicate the result of a client's request. The response message consists of 3 main components: the status line, the header lines, and the entity body. The status line is the first part of the response and provides essential information about the outcome of the request. It includes the HTTP version used by the server, followed by a numeric status code and a corresponding phrase. For example, a status code of 200 with the phrase OK indicates a successful request, while 404 not found signals that the requested resource could not be located. These elements are separated by spaces and terminated with a carriage return and line feed. Following the status line are the header lines, which provide additional metadata about the response. Each header consists of a field name such as content type or content length, followed by a colon and a value. These headers convey information such as the type of content being sent, its length, or caching directives. Multiple headers can be included in the response, and they are also separated by line breaks to ensure clarity. Finally, the entity body, highlighted in yellow, contains the actual data being returned by the server, such as the HTML content of a web page, an image, or a file. This section is optional and is typically included when the server sends a resource to the client. As introduced in the previous slide, the status code tells us whether the request was successful or if there was an error. For example, a 200 code means OK, meaning the request was successful, while a 404 code means not found, indicating that the requested resource doesn't exist on the server. These codes are essential for understanding what's happening when you interact with a web server and why something may not be loading as expected. This example illustrates the structure and content of an HTTP response message, detailing its various components. The response begins with the status line, which includes the HTTP version, a status code, and a status phrase. This indicates that the request was successfully processed and the resource is being returned. Following the status line are the header fields, which provide additional metadata about the response. A useful feature in HTTP is the conditional GET request, which helps reduce bandwidth usage and speed up browsing. When your browser requests a web page, it can include an if modified since header, which asks the server if the resource has been updated since the last time it was accessed. If the resource hasn't changed, the server responds with a 304 not modified status, and the browser can load the page from its cache instead of downloading it again. This mechanism helps save time and network resources. HTTP is a stateless protocol, which means the server doesn't retain information about previous requests. To solve this problem, cookies were introduced. Cookies are used to maintain state across multiple requests. A cookie is a small piece of data stored by the browser and sent with future requests to the same server. Websites use cookies to track user sessions, store preferences, and facilitate personalized experiences. The first time a user visits a site, the server generates a unique ID and sends it as a set cookie header. The browser stores this cookie and includes it in subsequent requests, allowing the server to recognize returning users. This diagram explains how HTTP cookies work to maintain state between a client and a server across multiple interactions. Initially, the client sends a usual HTTP request to the server. In response, the server includes a set cookie header in its HTTP response. This header assigns a unique identifier, such as 1678, to the client. At the same time, the server creates a corresponding entry in its backend database to track the user or their session. The client stores this cookie in a local cookie file. During subsequent interactions, the client includes the cookie in its HTTP requests. The server recognizes the cookie and retrieves the associated entry from its backend database. This enables the server to perform cookie-specific actions, such as delivering personalized content or recalling session-specific data. The HTTP response is then customized based on the cookie's information. The diagram also illustrates the behavior when the client interacts with the server after some time has passed, such as a week later. The client still includes the previously stored cookie in its request. The server, using the information associated with the cookie, can seamlessly recall the client's preferences or session data and perform actions specific to the cookie. This process ensures continuity and personalization without requiring the client to re-authenticate or re-enter preferences. In essence, cookies provide a mechanism for maintaining state in the otherwise stateless HTTP protocol, enabling servers to recognize returning clients and deliver tailored experiences. This capability is widely used for functionalities such as session management and customization. Another feature of HTTP is the proxy functionality. A proxy server acts as an intermediary between the client and the web server. When a client sends an HTTP request, the proxy server checks if the requested object is already in its cache. If it is, the proxy responds immediately, reducing latency and bandwidth usage. If the object is not in the cache, the proxy retrieves it from the origin server and delivers it to the client while storing a copy for future use. Proxies also enhance privacy by masking user identities and filtering web content. Specifically, an HTTP proxy acts as an application gateway at the application layer of the network stack. Proxies function as intermediaries, routing HTTP requests and responses between clients and servers. In other words, an HTTP proxy serves as a virtual host, meaning it operates at the application level, processing and forwarding HTTP messages. To perform its role, the proxy must act as both a client and a server. On one side, it acts as a client when sending requests to the origin server on behalf of the actual client. On the other side, it acts as a server by receiving and responding to requests from the client. When the client sends an HTTP request, it is first directed to the proxy. The proxy either forwards the request to the origin server or responds directly if the requested resource is cached locally. From the perspective of the origin server, all requests appear to come from the proxy, effectively masking the identity of the actual client users. This behavior is illustrated in the diagram where the client, proxy, and server are represented as distinct layers of the network stack.